So now we will see examples on continuous charge distribution. So in this example, you have to find electric field due to wire of length 2L, d distance above the midpoint of the straight wire, and charge per unit length lambda is given. So let us see. You have a wire of length 2L. This is a wire of length 2L, and you have to find electric field d distance away. This length is 2L, and its charge per unit length is lambda. So how you will calculate? Assume this is xy plane. So you have to consider an elemental length dx. Let us consider elemental length dx over this wire. This elemental length is dx, and that is x distance away from the midpoint. So what will be charge in this elemental length? Charge in this elemental length dq will be lambda dx. So you have to first find charge due to elemental length. So let us assume this field is, let us find electric field due to elemental length. So this field is dE1. So this field is dE1. Assume this distance is small r. So where small r is given by under root d square plus x square. So what will be mod of dE1? You know, according to Coulomb's law, 1 by 4 pi epsilon naught. dq is lambda dx by small r square. That is the field due to elemental length dx. Now from the symmetry, you have to consider all elemental length on this wire. So if you see towards right of the midpoint, field will vary in this region. And from symmetry, if you consider similar point towards this side, same elemental length dx towards this side, and that is again same x distance away. So this field will be dE2. This is also at r distance away. So magnitude of dE1 is equal to magnitude of dE2. You have to consider all elemental length on this wire. Since there is symmetry around O, that's why I have considered elemental length towards right and left, because they have different direction, but magnitude is same. And then according to superposition principle, you have to find resultant field. So you have to resolve dE1 and dE2 along x and y direction. So I have taken this length is capital L, take it as capital L. This is 2L. So assume this angle is theta. So this angle is also theta. This is theta and this is theta. I have assumed this. So what will be component of dE2 in this direction? This is dE2 sine theta. Component of dE1 along this direction is dE1 sine theta. And along this direction, what will be component? This component is dE2 cos theta. And if you see this component, this will be again, you can write this component will be dE1 cos theta. So along y direction component is cos theta, and along x direction component is sin theta. since magnitude of dE1 and dE2 is same, so in x direction resultant will be 0. So what will be resultant field DEX? DEX will be 0. And along y direction resultant of DEY is twice DE1 cos theta. So resultant field is along y direction. Now we have to calculate this field. So what will be EY field? So integral EY is given by, so resultant field E is given by EY y cap. This is the resultant field. So we have to calculate EY. So component EY is given by integral twice DE1. DE1 is lambda dx by r square into cos theta is d by small r. So if you write in terms of x, so this is 1 by 4 pi epsilon naught is also there. This is 1 by 4 pi epsilon naught. So take twice lambda d, that is common value, by 4 pi epsilon naught, and integral this r will give you dx by, this is r cube, so this is x square plus d square power 3 by 2. And what will be limit of x? X will be 0 to L. You can see x varies from this point, and from symmetry I have considered both sides, 0 to L, 0 to L. So we have considered both sides, D1 and D2. So limit varies from x 0 to L. So now you have to integrate this.
dy how twice d1 was.
Which one? You can see resultant along y. This is d2 cos theta, d1 cos theta. So along y direction they will add up. So that's why this is 2 d1 cos theta. So ey is integral of 2 de1 cos theta. Cos theta is d by small r. R is root d square plus x square. Now you have to integrate this. So how you will integrate? You have to use substitution method. Put x is d tan phi. You know how to integrate. So this will give you dx is d sec square phi d phi. And what will be limit of phi? So when x is 0, let us take limit phi dash will be 0, and when x is equal to L, then tan phi dash will be L by d. So now integral this Ey will be twice lambda d by 4 pi epsilon naught, and this will be, limit will be 0. Let's take it as phi dash, and dx is d sec square phi tan phi, and this value will be 1 plus tan square phi is sec square phi, so that is d cube sec cube phi. So we have to integrate this. Ey will be given by twice lambda d by 4 pi epsilon naught, limit 0 to phi dash, and this will give you 1 by sec is cos phi, so this is cos phi by d square d phi, or Ey will be twice lambda by 4 pi epsilon naught. You can see this is 1 by 4 pi epsilon naught into twice lambda by d, and what will be cos phi? Integral will give you sin phi dash. If you integrate cos phi, you will get sin phi dash. and you know tan phi dash is L by D. Tan phi dash is a known parameter is L and D. So we have to express in terms of known parameters.
Sir, x is equals to d tan phi, then if x is equals to L, so tan phi will be equal to L by d. How tan phi dash?
Just to I have taken limit, new limit will be in terms of phi dash. Just I have changed the notation. You can take phi also. Take it as phi, no problem. So you can take it as phi. What will result will be same. Just to distinguish you new limit, I have taken it as phi dash. You can take phi also. So now what will be sin phi? L by under root L square plus D square. So now you can write Ey as, this is the final answer, 1 by 4 pi epsilon naught. Sin phi, you can write this as twice lambda L by D under root L square plus D square. This is Ey. So finally we can write electric field is 1 by 4 pi epsilon naught twice lambda L square plus D square y cap. This is the electric field. Finally, you have to see this result. This is the electric field, D distance above the midpoint of the wire if its charge per unit length is lambda. So if you put L tends to infinity, you will get field due to infinite wire. So we will see how to write field due to infinite wire. So let us see what will happen when you have infinite wire. So in infinite wire, L tends to infinity. So limit L tends to infinity 1 by 4 pi epsilon naught twice lambda L D under root L square plus D square. How to solve this integral? So this limit will be, take L square common. So this is limit L tends to infinity 1 by 4 pi epsilon naught twice lambda L D L 1 plus D square by L square. So this will cancel out and this term will tends to 0. When L tends to infinity, this tends to 0. So final result will be 1 by 4 pi epsilon naught twice lambda by D, or that is lambda by 2 pi epsilon naught. This is the electric field due to infinite wire. So now you can see wire is infinite. Its charge per unit length is lambda, and you have to see what will be electric field at point P, that is d distance away. So this is the electric field. Electric field E is given by, this electric field is given by 1 by 4, this is lambda by 2 pi epsilon naught d y cap. So at this point, what will be direction of the field? Y cap. Is it clear? Same symmetry, but now wire tends to infinity. So at point P, you can see at this point electric field is upward direction. So when infinite, field is upward direction. So you have to remember this relation. What will be field due to infinite wire? Lambda by twice pi epsilon naught d y cap. In same symmetry, what will be field at any point below the wire? So if you have to write in Cartesian symmetry, this direction is minus y cap. At this point, field is minus y cap. So in Cartesian symmetry, at different point you have to show the different direction. But you know that wire has cylindrical symmetry. So you can easily express electric field in cylindrical coordinate. This I have written in Cartesian coordinate. For example, if this is the long wire, let's say infinite wire. So if you see point above, this is the direction. Point below, this is the direction. If you have any point in this direction, so this will be the direction. Opposite to this, opposite direction. So in Cartesian symmetry, you have to express in different direction. But in cylindrical symmetry, if you draw a circle around the wire, so at each point magnitude will be same because radius is, let's say, d, and direction in cylindrical symmetry is simply r cap because different direction is radially outward direction, that is r cap direction. So we can easily express this electric field in a cylindrical coordinate. So let us see, wire is, this is the wire, you can say it's an infinite wire, and wire is placed along z direction, its charge per unit length is lambda. At any point P, r distance away, what will be the electric field? Now wire is along z direction. So you know in cylindrical symmetry, cylinder is along z direction. So if you draw a circle of radius is small r, then at each point this direction is represented by r cap direction. You don't have to represent different direction because in cylindrical symmetry, each direction is represented by r cap. So we can easily write electric field E as lambda by 2 pi epsilon naught r cap. So let us represent field due to infinite wire in cylindrical coordinate system. So that is lambda by 2 pi epsilon naught small r. Is it clear? Why we have expressed electric field in cylindrical coordinate? Because wire has cylindrical symmetry. And direction is easily you can write as r cap because each direction is radially outward direction and that direction is r cap. So this circle is in xy plane. R we can write as under root x square plus y square. So we can write r cap, if you have to write r cap in xy plane by small r. So this is xx cap plus yy cap by under root x square plus y square. So you can write in another form also. In Cartesian symmetry, you can write this as lambda by 2 pi epsilon naught, and this is r cap. R cap is vector r by r, so that will give you r square. So this is x cap plus y cap by x square plus y. R cap is vector r by small r. So r square will give you x square plus y square. So you can also express in this form. Is it clear? Field due to infinite wire. Next question. So consider a square loop. You have a square loop of side small l. It's a square loop of side L, and you have to find field d distance above the center of the square loop. So you can write this problem. Let us write down. Because I have to use this relation. If you know field due to wire of length 2L, you can find field due to the square loop. So you can write, find the electric field let's take d distance d dash distance above the, take it as d dash instead of d, take it as d dash above the center of a square loop of side small l, or take it as a instead of l, take it as a of side a carrying uniform charge, uniform line charge lambda. So now you have to find field due to square loop. Side is a and charge per unit length is lambda, and we have to use this relation. If you know wire of length 2l, then we can easily find field due to square loop. So you can see in the square loop there are 4 segments of wire. Take it as segment 1, this is segment 2, this is segment 3, and this is segment 4. And due to each segment you have to find field at point P. So what will be electric field due to segment 1? Now this is this midpoint, then you have to find field at this point. This is E1. Is it clear? And take this distance is small r. This is the field small r distance away from the segment 1. So how you will write E1? How you will write E1? Use this relation. In this case you can see this length is 2l and you have to find d distance away. So this is the relation. So in this relation you can see this 2l is replaced by a. This length is 2l, this length is a, so you have to replace 2l by a. You have to find d distance away, and here you have to find small r distance away, so you have to replace d by small r. Is it clear? And this small r is under root d dash square plus a square by 4. I think this point is clear. How to write field due to segment 1? So in this relation 2l is replaced by a, and this d distance away you have to, in this case that is a small r distance away, so replace small d by small r. So you will get 1 by 4 pi epsilon naught. This is, write down magnitude because you know this is the direction, and you will get lambda into a by d is replaced by small r under root l is a square by 4 plus r square. This is the magnitude E1 due to segment 1. Is it clear? Where small r is this d dash square plus a square by 4. ठीक है? Similarly, you have to find field due to other segment also. So if you find due to segment 3, segment 2, and this is segment 4. So due to segment 3 you will get E3, due to segment 2 you will get E2, segment 4 you will get E4. All are small r distance away, so their magnitude will be same. So we will see mod E1 is equal to mod E2 is equal to mod E3 is equal to mod E4. So due to each segment at this point magnitude will be same. but their direction will be different. And what will be direction? You can see this is segment 1, so this is the direction, and segment 3 you will see in this direction. This is E1, so this will be E3. And similarly, if you see for E2 and E4, you will get E2, this direction is E2, and this you will get this direction is E4. At point P, you will get four direction. This is E1, this is E3, this is E2, and this direction is E4. Is it clear? Segment 1, 2, 3, and 4, and their magnitude will be same and direction will be different. I think this point is clear.
Yes, sir.
Yes, sir.
So now you can see, assume this angle is theta. So this angle is also theta. Write down this angle as, this angle is also theta. This is E1. So this angle you can write as, this is also theta. So if you assume this loop is in xy plane, take it as xyz plane. So in xy plane, you will get component is sine theta, and corresponding to each sine theta component, for example, you have 4 components: this direction, this direction, this direction, and this direction. This is in xy plane, and these are the sine theta component. All are the sine theta component. E1, E2, E3, they are the sine theta component. So for example, if this direction is E1, so this component is, you can write it as E1 sine theta. And this direction is E3, so this component is E3 sine theta. Similarly, this component is E4, so this is E4 sine theta. And this component is E2 sine theta. So in xy plane, sine theta component will cancel out. So resultant in xy plane will be 0. So in xy plane, resultant will be 0. But if you see along z direction, you have 4 components: 1, 2, 3, and 4. They all are cos theta component, and their magnitudes are E1, E2. You can see these components are cos theta in this direction: E1, E2, E3, and E4. So in z direction, component will add up, but in xy plane, component will cancel each other. So resultant will be 0. So resultant field you can write as 4 E1 cos theta, and this direction is z cap. So we can write E as 4. E1 is 1 by 4 pi epsilon naught lambda a by r under root a square by 4 plus r square, and cos theta is d dash by small r. Direction is z cap. So finally you can write electric field E as, this will give you resultant field E as 1 by 4 pi epsilon naught. You can write this as 4 lambda a into d dash by, this will be r square, so r square will give you d dash square plus a square by 4 under root, this will give you a square by 2 plus d dash square, and direction is z. So Just see, I have replaced small r by d dash square plus a square by 4. So r square term will give you this term, and if you put, yes,
Sir, d dash square plus a square by 4, it is under the root?
yes, this is under the root. This term is a square. What will be? Just see, I have written a square by 4 plus r square. R square is d dash square plus a square by 4. So this term will give you a square by 2 plus d dash square, and small r square will give you this term. First term is small r square, and this is root a square by 4 plus small r square. Is it clear? Find the electric field a distance small d above one end of a straight line segment of length L, which carries a uniform line charge lambda. So you can easily find in this case also. So this is wire of length L, and you have to find field at this point. This length is L, its charge per unit length is lambda. So you have to consider, again this is xy plane. So you have to consider elemental length dx, x distance away. Charge dq will be lambda dx. So this field is dE1. So what will be mod dE1? 1 by 4 pi epsilon naught lambda dx by small r square, where r is under root x square plus d square. Now in this case, if you resolve dE1, you will get two components. One is this component, this is dE1 cos theta, and another component is, this component is dE1 sin theta. So resultant field will be along y direction and minus x cap direction. So resultant field E can be expressed as minus Ex x cap plus Ey y cap, where Ex is given by integral dE1 sin theta and Ey is given by integral dE1 cos theta. So you have to integrate this. So you can easily integrate dE1 sin theta and dE1 cos theta. So let us see what will be dE1 sin theta. So dE1 sin theta will be, this is 1 by 4 pi epsilon naught lambda dx by r square, and sin theta term is x by small r, x by small r. X will be 0 to, now in this case limit will be 0 to capital L. So if you integrate this, you will get lambda by 4 pi epsilon naught integral x dx by x square plus d square power 3 by 2, x will be 0 to L. So now you have to integrate this. I am giving you final result. If you integrate this integral value will be 1 by d minus 1 by under root d square plus L square. This will be Ex value. And Ey we have already calculated, just limit is 0 to L. So if you calculate Ey integral will be 1 by 4 pi epsilon naught into lambda d integral 1 by d square plus x square power 3 by 2 dx x 0 to L. This integral I have already calculated. So Ey will be 1 by 4 pi epsilon naught lambda into L by d under root L square plus d square. So this is Ex and this is Ey. And finally you can express E as minus Ex x cap, Ey y cap. You can see the resultant direction will be y and minus x cap. So we have calculated Ex and Ey. E is minus Ex x cap, Ey y cap. This is the field at this end of the wire. So next example on Coulomb's law. Find the electric field a distance small d above the center of a circular loop of radius capital R which carries a uniform line charge lambda. So it's a case of circular loop. So in this case, consider a circular loop of radius R and its charge per unit length is lambda. And you have to find electric field d distance above the center of the circular loop. So you have to first consider elemental length over this ring. So let us consider this elemental length. Let us assume this length is dl. So what will be charge in this elemental length? Charge dq will be lambda dl. This is the charge in the elemental length dl. So we have to first find electric field due to this elemental charge. So at this point, assume this is dE1. Also assume this length is small r, where small r is given by under root r square plus d square. So we have to find magnitude of dE1. You can easily write from Coulomb's law what will be mod of dE1. So that will be 1 by 4 pi epsilon naught. You have lambda dl by small r square, dq by small r square. This distance is small r. So this is the magnitude of electric field dE1. Now for resultant field, you have to consider all elemental charge over this ring. And then you have to find resultant field. Assume this angle is theta. So this angle is also theta. And also assume that this loop is in xy plane. This loop is in xy plane, and so this direction is z direction. So this is field DE1 is because of the elemental length DL only. So if you consider all elemental length over this wire, consider all elemental length because it's a continuous path. So you have to consider all elemental length. So you will see around point P, you will get cone of DE1. So if you see around point P, this point is P, this is Z direction, DE1, DE1. So this is cone of DE1. If you consider all elemental length over this ring around point P, you will get cone of DE1. And then you have to find resultant of this cone of DE1. That will give you resultant field. So you have to resolve DE1 in XY plane and along Z direction. So in XY plane, you will see if you resolve it in XY plane, these components are, what will be this component? DE1 sine theta. So corresponding to each DE1 sine theta, you have opposite DE1 sine theta. Each component are DE1 sine theta. So in XY plane, let's say if this is DE1 sine theta, you have opposite DE1 sine theta. If this is DE1 sine theta, you have opposite DE1 sine theta. DE1 sine theta, opposite DE1 sine theta. So in XY plane, you will get disk of DE1 sine theta. Disk of DE1 sine theta. Corresponding to each DE1 sine theta, you have opposite DE1 sine theta. So resultant will be 0. Resultant in XY plane is 0. Resultant of field in resultant E in XY plane will be 0. And what will be component along Z? This component will be DE1 cos theta. In XY plane, component is DE1 sin theta. They will cancel each other. Resultant field is along Z direction. So what will be DE1? Resultant field along Z direction. So resultant field E is given by integral DE1 cos theta, and this direction is Z cap. So you have to find this integral. Integral DE1 cos theta. So we will integrate this. What will be integral DE1 cos theta? DE1 is 1 by 4 pi epsilon naught lambda dl by small r square. And what will be cos theta? D by small r. You can see this r is the constant value. So from this integral, you can take constant value is 1 by 4 pi epsilon naught, this lambda d by r cube integral dl only. And this integral is line integral. So if you integrate this, this will give you 1 by 4 pi epsilon naught lambda into d by small r cube will give you r square plus d square power 3 by 2. And what will be integral dl over this? This will be 2 pi r. This will be
2 pi r.
2 pi r. And then we can write the final field. This is the integral DE1 cos theta. So resultant field E is given by, in this 2 pi will cancel out. So you will get, or you can write this as 1 by 4 pi epsilon naught. Let us write in this form. Lambda into 2 pi r into d by r square plus d square power 3 by 2, direction is z. This is the resultant field. One by 4 pi epsilon naught lambda into 2 pi r. This is d by r square plus d square power 3 by 2. Now, since lambda is uniform, what will be total charge on the ring? What will be total charge on the ring? Lambda into 2 pi r. So if it is given that Qt is distributed uniformly over the ring, so you can also write in this form. Lambda into 2 pi r will give you total charge on the ring. So sometimes lambda is given, or sometimes it is given that charge Q is distributed uniformly over the ring. So you have to replace this by total charge over the ring. What will be electric field at the center? At the center, D is, so at the center of the ring, electric field is 0. So at the center, field is 0. So let us see next example. We will see electric field due to disk. And again, we will use this relation. If you know field due to circular ring, you can find field due to disk. So again, write down. Find the electric field d distance above the center of a circular disk. Circular disk of radius capital R, which carries uniform surface charge sigma. Now you have uniform surface charge is sigma. So let us see its solution. Now consider you have a disk of radius r. It's a disk of radius r, and its charge per unit area is given. What will be electric field at point P, that is d distance above the circular disk? So now we will use field due to ring. Let us draw an elemental ring of radius small r, and this thickness is dr. So consider an elemental ring. You have elemental ring of radius small r, charge per unit length lambda, let us assume this, and thickness dr. Also assume that its charge per unit length is lambda. So now you can easily write electric field due to elemental ring. So what will be electric field due to ring? You know this relation, 1 by 4 pi epsilon naught lambda into 2 pi small r. Lambda I have assumed charge per unit length on the ring, and radius is the r, small r, so lambda into 2 pi r. You have to again find at d distance away, so this is d. Now here you have to write r square plus d square power 3 by 2, and direction is z cap because you have same symmetry. Disk is in xy plane, so loop is also in xy plane. So this is the electric field due to ring, but here known parameter is sigma. Sigma is given, surface charge. Lambda I have assumed, so you have to express lambda in terms of sigma. So what will be total charge on the ring? In terms of lambda, you can write this as lambda into 2 pi r. And if you see in terms of sigma, This is sigma into 2 pi r dr. Charge per unit area. So this will be sigma into 2 pi r dr. So this 2 pi r will cancel out. So you will get lambda is sigma dr. So you can replace lambda by sigma dr. So what will be electric field due to disk? Integrate all the rings from 0 to capital R. So this will give you, this 2 pi will cancel out. Just write down 1 by 4 pi epsilon naught. Lambda is sigma into dr into 2 pi r into d by r square plus d square power 3 by 2, and limit will be 0 to capital R. So this will give you 2 pi will cancel out. So you will get, this is sigma d by twice epsilon naught integral, this is r dr by r square plus d square power 3 by 2, 0 to capital R. So you have to integrate this. So how to integrate this? Take r square plus d square is t square. So if you differentiate this, you will get r dr is t dt. Substitution method. Use this method. So electric field due to disk will be given by sigma d by twice epsilon naught. So when r is 0, t is d. And when r is capital R, t is under root r square plus d square. You have t dt by, this will give you t cube. So this is 1 by t square. 1 by t square is minus 1 by t. So finally you can write E disk will be sigma by twice epsilon naught and minus, you will get 1 by d minus under root r square plus d square. And if you see direction is z cap. This integral is 1 by t square, and 1 by t square is minus 1 by t. So that's why you will get 1 by d minus of this value. So this is the electric field due to disk. Thank you.